So now that we've completed our project pre-planning, we're going to go ahead and start doing the setup for our models and our controller and our views and getting all of those pieces in place. And as we go through and discuss those elements, one piece that I'm going to touch on that's new content is this idea of dependency injection and what it means to do dependency injection and why it's important to do dependency injection. So to start off with, let's jump back into the Word document that we had as well as our source code. And you'll notice from the Word doc that we put together in the last lecture, we've got our use case scenarios. And the use case scenario I want to focus on right now is the student use case scenario in particular. But we do have scenarios for all the different roles, and we'll touch on each one of these as we progress through the course. So with the student, we have 4 or 5 basic tasks. We have login, the ability to update a profile, to view a list of available courses and sections, and to finalize the selector and then print that selector. So with that use case scenario, we have particular models or classes that we need. The student and the course, I think, are the primary two that we'll need, and then the course selector and the course selector item. So within the MVC project, I've gone ahead and I've created a set of models. So these models are based on the Word document. So we have a model for our courses, a model for our course selector, a course selector item, a manager, a student. We have the student repository that we created last week, and I'll kind of review that in a little bit of detail. We have a teacher course. And then we have our entity framework DB context that we created last week as well with our student DB set. So those are all the models from our source code. I've gone ahead and made modifications to my student table by clicking Open Table Definition, and I've added additional fields to my table to incorporate the email address and password fields from our model. So we now have access to those through our model. One other modification I do want to make is I want to rename this to mail address, and then I'm going to go ahead and drop the city field because we don't actually need that. So we'll click Update and Update Database, and that will push our changes into our local DB database. Okay, so if we look again back at our use case, we've got these 5 actions or scenarios that we're wanting to work against for our student. So to do that, I've created a student controller, and to create a student controller, it's simply a matter of right-clicking on controller, choosing add, and then choosing controller. And in this case, we're going to choose the MVC5 controller, the empty controller, and we'll click add, and then it comes up with this small box and says give us the name of the controller, and for us we would choose student controller. Now inside of my controller, I've gone ahead and created 5 methods. These methods map to URL actions. So we have login, update profile, available courses, finalize selector, and print selector. Inside of each one of these methods, I've gone ahead and just put the basic return view, and that tells the controller, or rather the controller tells MVC, return the view that matches my name. There is a lot more complexity and a lot more work that we need to do as we kind of unfold or unpack this, but this is going to be our starting point for building our controllers and our views. Now, before we start digging into fleshing out the controllers, I do want to talk about a concept that I introduced a moment ago called dependency injection. Now, the idea behind dependency injection is that it allows your program to be built in a manner where you have interchangeable parts. So pieces of your program that may become dependents, such as a database connection, that then is injected into the program at runtime as to what the dependency should be. Okay, so that was a lot of words. So what does that really mean to you and I? Well, let's talk in a concrete scenario, something that we're familiar with. In the project last week under models, we created this student repository. And in the student repository, we have 5 methods. We have methods for get all students, get student by ID, add student, update student, and delete student. Now these 5 methods, their implementations are dependent on the the week 4 DB context. These 5 methods are then going to be utilized within our controller. So what we would do is we would say student repository, and we'll resolve that with our using statement, and then we'll just say repo equals new repo. So then this is the repository that we'll be using for student data. And then from here we would go in and we would actually implement our login. So for example, we would actually be pushing up a login screen, which would be asking for a username and a password, and then after doing that call, we would have a form submission that would submit back to us, and that submission would push to us the username and password that we would have to validate. The scenario that we're just talking about, the issue with it is that the student repository becomes a dependency that the student controller has. And that means that if at any point we decide that we want to change out the repository, that it requires us to do some fairly extensive heavy lifting, especially if we use the student repository throughout the entire application. We have to touch every place in our code where that student repository class is referenced, and we may have to make modifications, changes, or possibly removals to ensure that the program will compile after we remove that repository or made modifications or chosen to use a different one. So what dependency injection does for us is we actually take something that is concrete, like the student repository, and we create an interface to it. Now, if you remember from your C#, your contemporary programming course, interfaces allow you to build these blueprints to what a class should look like or should do. And the beauty of using these interfaces is that you can define that there should be specific methods available on any class that implements that interface. So with the case of the student repository, we need 5 methods. We need get all students, get student by ID, add student, update student, and delete student. Now, to take this repository and create an interface, Visual Studio is very nice for this. You can right click on the class name, choose refactor, and then you can choose extract interface. And doing this, Visual Studio will look at all the public members of this class. It'll look at the class name itself and infer from those 2 elements that the new interface should be called student repository, and that all the public members, the 5 methods, should be part of this interface. So I'm going to go ahead and take these defaults and hit OK. So what's now happened is we now have a public interface, student repository, that projects the add student, delete student, get all students, get student by ID, and update student methods. So with this interface, we can now use this as our type. Instead of having to create a variable that is of type student repository, we can create a variable that is of type student repository. And because our interface has these public members, we don't have to worry about what type of object we're getting on the right hand side. All we need to worry about is that this object from the right side complies with the contract or the blueprint that student repository defines. Now, the line of code on line 13 will work perfectly fine as is. But to truly have dependency injection, there needs to be what's called a layer of abstraction between the interface declaration, or the variable declaration, and the actual initialization of the object that is associated. Now, to do dependency injection, there is another concept that complements it called a IOC, or inversion of control container. That's a common practice that's used with dependency injection. There are a lot of different ones that are available. You can right click on references and go to manage NuGet packages. And from within the NuGet package manager, you can just type in IOC. We'll do a quick search on IOC. And you'll see that we get back a whole collection of different IOC containers. The textbook refers to Ninject specifically as being a recommended or preferred IOC container. If you're interested in using Ninject, I totally encourage you to do that. You can get more details about how to use it and how to implement it in the textbook. But since there is that resource available to you in the textbook, I want to go a layer deeper. And I want to talk about how does this concept of dependency injection work from a mechanical perspective. So instead of using one that kind of comes off the shelf, I want to go ahead and actually build for you a dependency injection class or utility class so that you can at least get a better understanding of how those mechanics work. So this here is my repository engine that's going to do my dependency injection. This class is a static class. So we have public static class repository engine, and then I have one static method that uses the generics notation. So it's a public static, and it returns a tResult, and tResult is the template placeholder for our return type. The method name is getRepository4, and then there's our template tResult again with no parameters. What will happen here is that we'll put in place of tResult on our call, we'll put the interface that we want to find an instance class for. So in this case, we would say iStudentRepository. So we would say getRepository4 iStudentRepository. Now, the mechanics that we go through is this concept called reflection. And what reflection allows us to do is it allows us to walk through the assemblies or DLLs or class libraries that are loaded in memory with our project and walk through each type to identify what types are available. At that point, we can do some logic to determine, is the type that we're looking at, is it assignable from iStudentRepository or whatever our tResult is. So to start off with, I'm going to capture the type of tResult, and this is actually the most basic type of reflection class is the type class, and that allows us to get projections of different pieces of information such as the properties, the members, the methods, the enums, events, fields. You can basically get access to just about anything about any type by using reflection. The next line then, what we do is we're going to tap into what's called the app domain. Now, every application that runs within the .NET framework has its own app domain. So we're going to tap into the current domain for our application, and we're going to ask for all the assemblies that are running in the current app domain. I went ahead and included this where clause to filter out the array of assemblies, and the reason I do this is that without filtering out any assemblies that have the word Microsoft or the word system in them, we tend to get about 70 or so assemblies that are returned within the app domain. A majority of these are either Microsoft published or they're part of the core.NET framework. And unless you're writing something that interfaces with those classes, it's usually best to try to eliminate them. That way you're minimizing the amount of looping or iterating you're doing across all the assemblies. It especially is helpful when you're doing debugging. So basically I'm saying here, get all the assemblies from the current app domain that are not Microsoft or system.assemblies. And then I can go into a for each loop, and I loop through each assembly one at a time, and then within that assembly I get all of the types or classes that exist inside of that assembly. I then do a logic statement and I say if the tResult type is assignable from T being the type that we're currently evaluating, if this is a true statement, then this class or type T is inheriting or is an instance of our T result type. So what does that mean to you and I? Let's assume that T is the student repository class. What this if statement is saying is, if I can take iStudent repository and it's assignable from student repository, meaning that I can take student repository and cast it into iStudent repository, this is a good match. This statement's a little confusing. I often get this mixed up myself whenever I have to go write it. I usually end up putting the T over here and the T result on the other side just because it makes more sense to say, can I take T and assign it from iStudent repository? So if that's a little confusing, you may want to play this back a few times and maybe even look at the documentation by choosing the is assignable from and hitting F1 and checking out those docs. So if this is a good match, then our goal is to create an instance of T, in our case, the student repository class, and return it as iStudent repository. And since student repository inherits or implements iStudent repository, we can then go ahead and cast them back and forth freely. So this is the basic mechanics of any inversion of control or dependency injection container. Inject obviously has much more functionality. There's many more classes within that framework than just using a simple class like this. But just to get an understanding of what these dependency injection containers or IOC containers are doing, I felt it was good to at least have some experience or understanding of what this is. So now that we have our repository engine, we can go back to our controller, and instead of just simply saying new student repository, we can say repository engine get repository for iStudent repository. And by calling this, the engine will go out and find student repository dynamically and then create an instance of it and return it to our repo variable within our controller. Now within the login, I've gone ahead and just created kind of a dummy set of code here. So I take my repo and I say get all students, and I store those in S, and then I'm passing them to the view. Now I need to create my view, so I'm going to right click and say add view. I'm going to have it be called login, and I'm going to leave my templates as their default for now, and that will return me a new empty view. I'm going to make some modifications to this view. I'm going to add a strong type to my model binding, and I'm going to bind it to student. And then I'm going to insert a quick for loop. So this for loop will basically loop through every student in the model, and then it's going to display the first name, last name, and student ID. So if we go ahead and do an F5, we'll compile and run. And what has occurred is that we have an inner error, so let's go ahead and open up our exception details. And this says cannot create an instance of an interface. So let's examine here real quick since we are in debug. So tResult is looking for, I'll do it up here, iStudent repository, so that's our interface that we passed in, and then we are looking at T, and T is also the interface iStudent repository. So this statement is a true statement because you can cast anything that is of type iStudent repository to iStudent repository. So we need to build some additional logic in here to exclude that. So let's say if this is assignable and T dot full name does not equal T result type dot full name, then it's a good match. So this should hopefully keep us from running into ourselves when we're doing our run. So let's do an F5, we'll rebuild again and redeploy. And we're going to connect to student/login. and that's much better. So what has happened for us, if we jump back to our controller, I'm going to actually go ahead and put a breakpoint here on line 14, and I want to refresh again. And we'll just walk through this briefly. So what's happening is we have iStudent repository for the repository engine. So we're saying get a repository for iStudent repository. If we step into that, we'll walk through some of these basic mechanics here. And we have our type instance of iStudent repository in tResult type. Under get assemblies, we now have 15 assemblies that we're looping through. So we have things like Antler 3, Entity Framework, Newton's JSoft, WebGrease. There's our week 4 MVC DLL, and then there's some additional DLLs that are loaded as well. So with all of these DLLs that are being enumerated through, we want to go through and loop through each one of them. I'll go ahead and put a breakpoint here, and we can just look real quick at what's being evaluated. So this is iStudent repository, and it's checking to see if T, system.object, can be cast to iStudent repository. In this case, this is a false statement. So what'll happen is it'll loop, and then it'll go on to the next type. This is iSerializable. So is iSerializable, can it be cast as iStudent repository? False. So I'll go ahead and jump a breakpoint here, and we'll let it continue to loop through, and then finally we land on student repository as our type. It is castable from iStudent repository, and it is not iStudent repository. So with those two factors in place, we can create an instance of the student repository, cast it to an iStudent repository, and return it. So if we jump back up out of this loop, go to the next line, repo now equals an instance of student repository. We then can jump into our login method. We can call getAllStudents, and then we can pass that collection of students to our view. Passing that collection gives us a spit out of all of the students out of the database with first name, last name, and student ID number. So we've now gone through these basic mechanics of doing model building and dependency injection. So with these two components, we're now able to go through and finalize the building of our MVC, first phase of our MVC application.